Yeah, so I asked, what is a uniform? What is what we're forced to use in high school? And you said, and you can't change it. All you can do is use it, and then you go get another pair of it or something like that. Okay. You can only insert something into the uniform. I guess that's the best way to put it. So, if you're gonna set your code up when we go to talk to the card, all right. All of you have a shader program, I'm assuming.
Yes.
And you have to send data to it. We're going to talk about uniforms. Okay. Depending on syntax, you can actually have specific layout locations for the uniforms. All right. You can say like layout location is 0, and then say uniform, and to go on about your business. I'm doing some research on it, but I'm not completely familiar with it, as opposed to just like how I'm about to just show you to set it up. So, uniform. This is coming from the main program. At runtime. Okay, so this is in the runtime, uniforms. The syntax for it is just uniform type variable name. Alright, so uniform float and then time, uniform vec4 time. So quick question, when you say vec4 in GLSL, where is that vec4 coming from? Yeah, fair enough. Were you going to say the same thing GLSL? He was. And I am recording it. What else is called vec4? The stuff that comes from GLM, right? Yeah, I mean GLM has nothing to do with what we have going on. So if you're looking for documentation, I'll be posting a link to the useful OpenGL documentation from the Kronos group. They have some updated docs. I don't know how to integrate it with like hover compatibility right now. Yeah, like just pasting the code, the docs folder inside your project. But anyways. Not to be confused with GLM's vec4. So you're going to have some very similar functions like cosine, sine. I don't know about atan too. It might be a thing. Dot is still it. These are the functions that I'll say. So this is all about GLSL and shaders. The other really important function that you'll see is something like max.
That's mine.
That's yours.
Texture.
Okay. Max is going to take in 2 arguments, and what it will do is, it's not to be confused with clamp. It's going to take the maximum value of the following, which will always give you 1. Okay, yeah, so it always give you 1. So something like max, 0, and then That's it. So this is the Lambertian term, and this is the first thing we're going to start with. I'm going to put it on the board just so you can kind of see exactly what's going on. Is that forgetting about just this and this, right? These are vectors. Vector. Right now you can just assume that these are vec 1s, vec 3 1s. All right. So they're fully colored. So you got white and white, and then you have the L, which is the sun.
It's from the point to the light, right?
No. It's the light's direction. It's the light's direction. But I mean, you would invert it. Okay, so the reason why I say no, I mean it's okay, it is a direction from the point to the light, but like do not do this minus this.
That minus that.
Just set this, okay? Like you would set this, and then like this will have a light direction, okay? And then what you would do is just negate it. All right. So negating this will give you this. All right. So for every single one of these, you'll get the same vector, right? So does this maybe answer your question why I'm saying like position from light? Because the if you do this one and minus this, it's going to give you that, and that's not what we want at all yet. We are going to want it here in a second. So yeah, this right here is going to be L, and what we want is negative L. All right. Looking hot. So if your normal is 0, 1, 0, and then your direction is going to be 0, 1, 0, what do you get?
-1. -1. 0.
They're the same.
Is that the negated version or the non-negated?
This is the negated. This is the negated version.
Oh, okay. Then 1.
Yeah. I mean, L is the like this. Negative L goes straight up. Normal at this point is, straight up. Okay. So you have L like this, N like this. The dot of these two gives you 1. So then you take the max from 0, 1. You get 1. Okay.
What's the point of doing that?
What? Which one?
The max part.
I'm about to show you.
Okay.
What happens if I have this right here for a normal point to be here? All right. So we'll erase these right here and just say what's the dot product of these?
Might be 0.
Ooh, I got it.
You got it because you. What do you mean?
I get it.
All right. So you got this guy. So he's going -1, but then what about this guy? This is really the one that's. I hope you would just go. Wow. So like now you have this -1. Dot product of these. -1. Pi. Cosine pi. -1. So what about this guy?
0.
What about these guys? We already said this one. What about these guys?
Extra.
Jesus took you.
Huh?
0.3.
Wait, what?
0.3.
And for both, right? Bigger than 0.
Yes.
So basically what I said is that you have a color over here. And as you hit and go this way, like I don't know how to color it other than
It's making sense.
like I'm not actually fucking remember. Like it becomes like shaded. Okay? I don't know how to color, like I don't have a pen up here, But yeah, so what it's gonna do is like it'll start strong here and then go, it'll fade around it.
Yes.
Because what we're doing is we're saying, okay, just making sure that we're within this range. All right, this is going to give us the shading effect. All right, we just need to determine what the colors are, and then I'm going to go ahead and do it here in the code. So yes.
We are not at all taking into consideration the scattering of light, right? Just the reflection.
This is to represent the scatter.
What I mean by scattering is like when it hits, like so yeah, the dispersion of the light.
This is how we make it up. This is the approximation of it.
But okay, in this, for that ball, that whole bottom part would be completely black.
Mm-hmm.
But what I'm saying, like, if there's a solid surface beneath it, the light that hits the surface will scatter and light up the bottom of the ball.
Depending on the density of the ball itself.
Function match return to float.
No, not going through the ball. I'm talking about around the ball. Like,
Does anybody have a ball? They call Rob and get him buys a ball.
Who's ball?
like I mean, I know football. I feel like we could pretend this is a ball. How big of a ball? You know, the light that hits this, like before the.
You got me. Okay, so give me the ball. All right. Is the light in there?
Well, no, but
Is that what
I mean,
you're trying
if
to
it's
get?
that close, but like if you lift the light up, like up here.
It's well, I'm gonna need to.
Okay, just put
Because
your
it's a
hands like this.
directional light, it hits and then it, like it's gonna diffuse around.
Cup your
So,
hands
but
at
to
the
answer
bottom.
your question about like the, thank you very much, Black Panther. Yeah, that'll probably be my last year here. Not about you. So his question was, we're not mimicking the scattering of the light, but we. Let me get back to it. I don't want to fumble it. You know, I do know the answer, but I'd have to do it justice. So we'll talk about it when we get more into the actual lighting equation again, especially when we talk about the halfway vector with blend foam. Okay, you had a question? You just okay. All right. So what did we do? We basically discussed like this shading effect that we're gonna have with when we calculate the Lambertian term. We said that these right here are going to be vectors, okay? So two vectors that are going to be multiplied, then added to this thing, okay? And no, for right now, we're not worried about this right now, okay? So we have to get the information to the program. So we'll go ahead and do that. I have the basic setup for it here. Okay.
You go over material.
Can I go over the material? So in the shader? You talking about like this data structure or material like?
That's a shader. That's your.
Yeah, I'm in the shader right now. I did this on purpose, just to show you. You don't need to just have all of your stuff laid out in the shader. You can be organized about it. You can also have functions inside of the shaders. Okay. I did a tutorial, the Seattle tutorial they had. Their code doesn't match ours word for word, but they are doing things like writing functions inside of the shaders, and then they're grouping stuff up, being real neat about it. So I wanted to kind of hopefully share that, guys, with you as well. It's not something we've done in the past years. So yeah.
I'm assuming it's possible to have multiple light sources in phone lighting.
Yeah, that's what the E is for.
Oh yeah.
We took the E out.
Yeah.
Yeah, so like the stipulation is that the L is an LM, the R is an RM,
Yeah.
but we only have one light just for now. Okay. hopefully whenever you guys are given the final assignment, some of you will try to implement a 3-point light system with the key fill and backlight. Yes, there it is. That would be that would be really cool. Okay, so code. All right, so where are we right now in code? What we're doing is we've set the shader up. This is something all of you know how to do. What I've done is provide some examples here. Nothing.
It's mad, Mr. Man.
No, it's no, it's a picture in the code as a comment.
I can't.
But it's
I can't get hype about that. Well, it's the math. I'm gonna leave it as it is. Math. It'd be cool if it was like, you know,
No matter how it looks, it's mad. Don't make it.
Good job.
You could
Good
spell
job.
that equation out in diamond letters and it'd still be like, nah, it's math.
Potentially
Hey, remember you recorded. Be good for what you about to put up. Good job, bro.
nice.
By the end of this year, I'm gonna have all these equations just
With the assessment, are we gonna have to generate a sphere and then calculate all the normals on it?
Mm-hmm. I'm about to do it right now.
What is the other lighting called? Not phone lighting, but something phone lighting.
Blend phone.
And
What
what
phone?
are the differences again?
The calculation and the reflection.
Okay.
The reflected light.
Does it look bad?
REM.
Does it look better or does it look more correct?
Does it look more bad?
Is that get you hype?
Does it hit home? It's a picture, but it's a comment. Okay. It's like, okay, thank you, got it. Had nothing to do with anything that we're doing right now.
C3 coming soon.
I know. All right. So let's get to it. Now we need to bind the uniforms out. The thing that you guys have been binding so far is you've basically been doing the projection view matrix, okay, and then multiplying that by the model matrix. So you have your model view projection matrix, and then you send it out. So projection view model right here, this string value to be associated with the Fong vert right here. So that's this, okay? That's that mapping. We need to get the mapping for the other uniforms though. So let's do that. All right.
PVM, the camera projection view. You don't have to load that in again. You can just throw that around if you use a different shader.
That's a good one, dude. So we actually, we're not going to do it today, but you will need to send the model matrix separate. Because what happens is for non-affine transformations or non-uniform transformations, the normals do not behave as they should. So if you take a ball and you scale it, the normals are going to come in and they're going to, you know, scale properly. But as soon as you take a ball and squish it like this, the normals for that ball are no longer going to be pointing in the correct directions. Okay, does that make sense?
Yeah.
Yeah, like this is the ball with these normals, like the sun. Okay, if you make this smaller, it's the same normals. If you take this and then make it like this, this normal is going to be right, this normal is going to be right. However, these are going to get like skewed almost. And that's not right. We need to have this be properly done. Okay? In which we would send the normal matrix, which is the inverse transpose of the model matrix. You asked. I tried to protect you, but you asked. We're not worried about it now, okay? The goal of today is to be comfortable with uniforms, sending them out, and then calculating just the diffuse portion. So, let's go about doing it. The Fong.frag, alright, has the following data structures inside of it, and then these are the values associated with those data structures. Okay, so if you want to send something to light's position, okay, you would need to access it like this. So you make a handle for your light uniform. Well, we'll just do int for right now. Not supposed to do that. mshader get uniform, the variable name being light, then 0, and then, oh, I need to do this. Okay. So light 0 dot position. It's so you need to get the location of each individual field, okay, of the struct for the array element, and then send the value separately. Okay, so you're accessing. So you say uniform light 4, and then let me see what this guy's sending out. Light, and you send 4 values. This. Yeah. So let me just show you real quick. Yeah.
Why don't you just send the whole light?
I want to, but I'm just following this example that they gave me. But yeah, sending the whole light, man, that's that's really what I want. I really want to do. All right, I'll do it. So yeah, you would. If we're gonna go about sending it, Captain, just winging it now. So. So we'll do GL get uniform location. We're gonna need to get the handle for the program. That's gonna be please give me the handle. Yes, this is a win. All right, so we're getting a uniform location on this program, the current shader that's bound right here, and then we are going to need to access the actual variable being light, like this. And then I'm wanting to say that we can do GL uniform vec3 FV, and this is where the I want to say the count comes in. GL uniform. Yeah, because we don't have the ability to tell it how many we're gonna send it. Let me not wing this, don't worry, because I feel like it's gonna fumble and we're gonna miss out on it. So, this right here, it specifies that you have to put the 0 right here and then send in the very first element. So this right here is actually the same thing as using the actual shader itself to do get uniform, and it's going to this. And then we're just going to send in a value. Mm-mm.
What is direction underscore aim underscore directional light? It's an object.
Mm-hmm. It's a vec 3.
So it's just declared as GL and vec 3 aim underscore directional light.
Yeah. Okay. Okay. Okay, so now that we've successfully sent this thing off on its merry way, we're doing GO uniform 3FB, we're giving it the handle, we're telling it how many we're sending, which is 1, and then we're going to send it the directional light's direction, okay? So what I'll do is I'm going to take away the actual position of the light, okay, so that we're maintaining what this thing is saying. And then now that we have the direction of this light, okay, what we'll do is multiply, well, we can actually come up with some code here to actually calculate this term. Oh, I don't have it. The term for the diffuse, okay? So let me make sure that this runs. And expected behavior, oh. It's still running. All these sighs just do wonders for my confidence. I hate all of you.
Oh, it should just restart. No. That's the solution to our problems.
Yeah, you're right.
I don't know how the application started. Just all randomly like that. I'm a grown man. I can take it. Okay, so let's run it and see what we get. Okay, so we didn't get any errors right here, which is cool. So now that we have the light's direction right here, what we'll do is we're gonna make another uniform. Okay, and then do the following. So we're gonna send in the colors now. Alright, so we'll send in the diffuse color. So right here, this is going to be light 0 dot ID. Well, what? KD?
He was starting the diffuse function.
Okay, so now we're sending in whatever we're defining to be the directional light's diffuse color. And then what we'll do instead is, so for the frag color, we'll actually just set it to be the light dot ID. I think you would need to, well, no, you're accessing this member variable and then using the things inside of it. So I think it would be light 1 actually. Let's see what we get. If it comes out with a big ball that's like there, then it's something went wrong. Yeah, it doesn't like that.
Uniform light.
Assignment of incompatible types. So let me try this. Light dot.
Is that an array?
Mm-mm.
Shift that thought.
But no, what are you calling from like uniform light, uniform material?
So direction and ID.
You can declare those as uniforms. Shit. Uniform vector direction. Uniform vector ID.
I don't see the syntax problem. Does anyone see the syntax problem?
With what? You're not declaring direction or ID as a uniform. So how will I ever get it?
Thank you. Thank you.
Yes. Hey there, boys and girls.
Why we're giving them VGF. Baby. We're back.
And abuse.
Oh, come on.
I was ready singing, man. That was not.
I was in the house. Come on, man. I was there.
Your mouth was moving.
I was young. Your power. Get in there.
I was yawning with melody. Alright, so the problem that he said before, I'm really ready to just sit down and be quiet. This is totally not going up. Alright, so the thing that Trina mentioned was that I don't have a uniform, man. You can't just have these all out here all willy-nilly. So you did you? I couldn't hear you over Queen Bee over here.
Oh, boy. Assignment of incompatible. Right. Oh, you got swizzling on in your somewhere in the GLSL stuff. The direction is vec 3 and the fractal is vec 4.
This dude wasn't even here. Maybe you're fresh. No, he's right. So what I'm sending is a vec 4. Well, is it though? The direction right here?
In the shader itself. Void main line 25.
No, so these are vec 3s.
Frag color equals ID.
That's what's up. So yeah, this is gonna need to be a vec 4, taking in a vec 3, with the last item being 1. So what did we do? We colored it white. What else did we do? We learned that we shouldn't wing just these data structures like this, especially on the fly like this for this tutorial. So now that we know that we can send values to this, what we're going to do is send the rest of the values, okay? The rest of the values being these guys right here that make up this equation, okay? So all of this right here is going to need to get sent. All right, so what we'll do is we'll send the ambient light. All right, so we'll copy this guide over, bring him here, and then do, I think it's just ambient.
So you said that no matter what ambient is pretty much always going to be in the
In the equation.
So do you even need to add it?
Yes.
No, I meant like diffuse. There's always going to be ambient light. You said like in the lecture yesterday.
Yes.
But I don't know if like they were just contemplating or not. I don't know. Like,
What's the question? Do we need the? Do we not need the ambient light?
well, from what I got yesterday was like it's going to be created with the diffuse sensor.
I sit on. Well, I'll try to explain it to you. Like, you have to have an ambient light. The model states that it must have an ambient, a diffuse, and then a specular. Okay, the added or the combination of the three together are what make the actual light model. All right. So we're gonna send the IA. We're already sending ID. We'll send the important guy being the direction, and then do the Lambert calculation, and I'll show you guys how it's about to get interesting here. So direction, and then this is going to be geo uniform, and then we'll send a light uniform. And what are we going to send it? We're going to send it the directional light dot direction.
Wait, why are you putting in?
Oh, I am sending it. Okay, sweet. So sending the direction, sending ID, sending IA. Yes.
How would you go to break this apart more? How would you go to break that apart? Is this all in the draw function?
This is all in the draw function.
What's the standard for something like this for like?
For this tutorial, this is the standard. I'll get through the tutorial, give you the tutorial. You still have to do the tutorial, so we're an hour and a half behind. Now let's go about doing some math, okay? So what did we need? We need KD, ID, we need L, and we need the normal, okay? So the normal is going to be sent along with the vertex shader, as you can see. The normal, okay? If I want to get this normal from the vertex shader to the fragment shader, I'm gonna have to send it along its merry way, okay? So what do I mean by that? Well, you're gonna need to declare an out, okay? You're gonna need to say what type it is, which is going to be a vec4, and then what we are gonna say is it's just v normal. All right, this is a bit of a convention because it's the vertex normal. All right, I was last night when I went home, I did some research on vertex normal versus like per pixel lighting versus per fragment, or per vertex versus per pixel. And the forum discussion that I was reading stated like, which one is better? Okay, it's not a matter of which one is better. It's a matter of accuracy, okay? If you have a box, you would probably want to do per pixel lighting because you're going to be using normals relative to the surface there. Like the points, the vertex, the points that that you have are not going to really help you out in determining how to color something at the corner of something, okay? However, we have a ball, so we're actually going to get tons of accuracy in regards to, you know, per vertex lighting, because we're doing it for every single vertex. Does that make sense to you guys? Okay. So it wouldn't hurt to just send almost every single thing here already to the fragment shader, okay? The more information that you have in your fragment shader, the more like cool stuff that you can do with it. So what we'll do is we're gonna out the normal, and we'll also out the position, and then we're going to out the color. We'll out all of it. That's UV? Yeah, that's UV. And that is for textures, correct. So, and then we're gonna out the tangent. Okay, so now that we're outing them, we need to actually assign them values. Okay, or what? It won't give you an error right here. It's not. It's only bad because I'm not funny right now. So the thing that Trent said was he said that we would get errors. You won't get errors. You can out whatever you want. You're gonna get errors whenever you don't assign values properly here. Okay. So we have to get it out of the vertex shader into the next stage, being the geometry stage. Okay, but we don't care about that. We're gonna funnel it through everything until it hits the fragment shader. Okay. So here we go. So what we'll do is we're going to assign V position to position, and then we'll assign V normal to be whatever normal is. We'll assign V UV to be the UV, and then we'll assign V tangent to be tangent. Okay, so this is just a pro tip. Like if you're outing this and you know that you're going to send it to the fragment shader, just copy it, okay, and then in it here. And there we go. So what we'll do is we'll hit play and see that everything seems to be still working properly. Okay, so now let's do some coloring of this ball. So the first demonstration I want to show you guys is if we just color it based on the normal.
I hate to stop you from talking, but I need you for a minute.
Okay.
Right now.
Yeah, I'm coming.